Let's use this problem to review exponential growth and decay. This problem is about bacteria. The number A of bacteria in a culture is given by the exponential model. A is equals to 175 times e to the kt, where t is the time in hours. Starting at the initial time, 8 hours later, the population is 450. So given is A equals to 175 e to the kt. And then k is the rate, and then t is the time, A is the population after t hours, right? So let me make this look like k and a t. So that is a k, that is a t. So the given is when t is equals to 8 hours later, the population at that time is 450. And then we can use this given condition to find the rate k. Let's do it. So I have 450 equals to, again, I haven't answered any of these questions yet. Oh, but if you take a look at part A, find the rate k. That is what we are trying to do, because that is the only thing you can do in the first step. Without the k, the rate, we cannot answer the rest of the questions. Okay. So when A is equals to 450, that is 8 hours later, the initial population 175 e to the, don't know k yet, t is 8, so that will be 8 times k. And then we have to solve for k. Let's divide both sides by 175. So 450 divided by 175. There is no need to reduce this fraction at this point. And then e to the 8k. How do we bring the k down? To bring the k down, we have to take ln on both sides. So I'm going to use a different color to write that. So I'm going to take ln on the left and then take ln on the right. So we can bring the 8k down, and then the ln e is equals to 1. So back to my color. So I have ln 450 divided by 175. That is equals to 8 times k. And then multiply ln e, and then ln e, that is equals to 1. And then the rate in exact value is ln 450 divided by 175, so that is equals to 8 times k. Okay, and then this one you approximate that. I will just keep the k in 3 decimal places. So k is approximately equals to 0.118. So that is the rate. So since k is greater than 0, and this problem is exponential growth. Exponential growth. You can say as time increases, the number of bacteria is increasing exponentially. Okay, and then yep, we just finished A. So actually, this is my part A. I found K, and then I said that this is an exponential growth. So the number of bacteria is increasing. Why? Because k is positive. And then B is rewrite the model using the rate you found in part A. Okay, I can do that. So for part B, so that will be A equals to the initial population times the XE, base E, and then K is 0.118 times T. Now, I can use this model to answer the rest of the questions. And then the next one is estimate the population after 100 hours. So T is equals to 100. Let's do that in a different color. So C, when T is equals to 100, what is the population? So A is equals to 175, and then E to the 0.118 times 100. If you are following this, don't just take the numbers I give you. Use your calculator, plug in the numbers to see, make sure you can get that on your homework, on your test. Make sure you can get the numbers when no one is helping you out. Okay, approximate that is a pretty large value. I did that already. So that is what I got, 19161.77. That is the number of bacteria. So bacteria cannot be 0.7, right? So you have to round this to the nearest integer. So that is 233,191,62 bacteria. Okay, so after 8 hours. 8 hours later, there are that many bacteria. And then what's the last one? Part D is estimate the time required the population to reach to 900. Okay. All right, so that will be part D. What is T when the population is 900? Okay, so that will be 900, right? Equals to 175 e to the 0.118 t. We have to solve for t. Just like how we solve for k, I divide the initial population on both sides. So 900 divided by 175, so equals to e to the 0.118 and then t. To bring the exponent down, you have to take ln on both sides. Let's do that. Let's use orange. ln, so bring the exponent down, and then we can keep working on it. So we have ln 900 divided by 175 equals to 0.118 t, and then multiply lne, and then lne is equals to 1. And then let's bring it over here, shall we? So we have t equals to ln, so that will be a 900 over 175, and then divided by 0.118. What do you get? So I solved the problem already, so this one I have 13.9 hours. I would say round this to one decimal place is enough. I use one decimal. What is one decimal place? One decimal place is you have one number on the right hand side of the decimal point. Okay, so that is the end of this problem. If you think my instruction is helpful, like this video, subscribe to my channel for more contents like this. As always, I will meet you all in the next one. Signing out.